Dear students, here we are, AS Physics, Chapter 4, Forces, Density and Pressure. We have actually discussed earlier two lectures based on forces, density and pressure, and in which we have already discussed the situation of torque and moment and all these things. Today we are going to discuss the last two topics, pressure and upthrust. As far as these two topics are concerned, of course, these are very easy topics. You have been studying pressure, I think, since grade 8. So this is not a big deal, but of course, we have to discuss upthrust in detail. Here, as far as the definitions are concerned of these terms, like we have first term is density. As you have been studying, density is very simple. Mass per unit volume of a body is termed as the density of the body. Density is represented by rho, m is the mass, v is the volume. So simply you can write the formula in words like this, or with the symbols, rho is equal to m over v. As far as the unit of the rho or density is concerned, you know that it is kg, meter per meter cube. So it's very simple and easily remembered things. Then we have pressure. So we have been studying pressure as well, and it's simply the normal force acting per unit cross section area. And if you have any surface, so what force you have on this surface, this is giving you the pressure thing. And suppose if you have here, you have this area and you have a weight over here. So this weight of course will apply a force on this, and because of that force, what you will get, the pressure on the area. If the area will decrease, of course the pressure will increase, and if the area will be a greater area for the same force, the pressure will decrease. So these are few things which you have already studied in your IGCSE and O level, so I'm not going into that detail. Simple, P is equal to F over A, force per unit area, and you know that the unit of pressure is nothing but Newton per meter cube, Newton the unit of force, and meter square is the unit of the area. So meter per Newton per meter square will give you the unit of pressure, or simply you can say Pascal. Newton per meter square. Here we have kg per meter cube. This is termed as Pascal. Then you know that if you are talking about the pressure in a liquid, then you can simply say that it will increase with the depth and also increase with the density. If you suppose are performing any experiment on the surface of the earth, then g will be your constant, but when of course the height will be more, height of the fluid, so or liquid will be more, so pressure will be more. Density is high, of course the pressure will be more. And if you will change the position, instead of doing this experiment or performing any experiment on the surface of the earth, you are performing this experiment suppose on the surface of the moon, then as the value of g decreases, from 9.8 meter per second square, the value is 1.6 suppose meter per second square, then you can see there will be a change of pressure as well. So this is something which is of course important, but you have already studied, so quickly I am just going through these definitions and these units. Then here you have a sort of derivation for this P is equal to rho GH. Here we can derive the you can say pressure thing. The simple point to remember is that here we have the surface which we are using our term as the flat horizontal surface at the depth h. So if you have a liquid in this container, then what will happen, due to this liquid in the container, there will be a pressure on this surface area. As far as the mass is concerned, so as we have just said that density is mass per unit volume. So if you want to write mass, it will be density time volume. So this is something which is very important and basic term. So mass of the fluid is basically liquid and gases both. but for the time being we are considering suppose a liquid here, and the density of the liquid multiplied by the volume, you will have, this is your simple formula, density A into H. Here you have the area and here you have the height. So when you will multiply this A by H, you will get the volume. Area, here you have the area and here you have the height. So when you will multiply these two things, you will get the volume of this container, or simply you can say the volume of the liquid. So here we have the situation of the volume, which is AH, but when you will multiply this by the density, you will get mass of the liquid. Now remember this very simple thing, that with the help of the mass you can get the weight of the fluid, and the weight is nothing but W is equal to M into G. So mass, you have this one, rho AH, and then you will multiply this by G, you will get the weight. Weight is basically the force which this liquid is applying on this surface. So the force acting on the flat surface is nothing but because of the weight, or is the weight of the liquid or fluid. So this is very important. So this is simply, you can say, the force we are talking about. And here, as we have just said, that pressure is nothing but force per unit area. So what you can do, you can use this weight or force here. So rho GAH, and over here of course you have the area, because you know the formula is force per unit area. So what you will get is, will cancel out, and rho GH you will get. So if you will consider only the pressure because of the fluid, then this is the simple formula, P is equal to rho GH. But you also know that when we are living or we are on the surface of the earth, so we have the atmospheric pressure as well. So if you want to know the total pressure because of this liquid or fluid and the atmospheric pressure, so simply you can say that the sum of these two, yani the pressure due to the liquid or fluid and the atmospheric pressure, when you will add both these two things, you will get the net pressure on this surface. So this is something which we have to consider. It depends on whether they are talking in terms of atmospheric pressure or not, but truly speaking or practically the situation is that not only the pressure of the liquid you will have, but you will have the atmospheric pressure as well. But remember this thing, that this will be a situation when your container is an open container. So if you have a closed container, like suppose if you have a bottle which is closed with a sort of cork, then whatever the liquid you have here, only that liquid will apply the pressure, because the atmospheric pressure will not be active that time. So in that case only P is equal to rho GH works. But as I said, that if your container is open, then what will happen, not only this liquid but the atmospheric pressure will also act, and you will say that the total pressure is nothing but rho GH plus the atmospheric pressure at the liquid surface. I hope it's clear. I repeat, simple thing is that P is equal to force per unit area. So first of all you need force. So what is the force here? Here you have the force, the weight of the liquid or fluid. But what is the weight? How you will get the weight? This is the weight, but of course before the weight you are talking in terms of the mass, and to get the mass you are using this equation, density time volume. How you are calculating the volume? The area and the height. Area multiplied by height will give you the volume. When you will multiply this by density, you will get rho GH, which is nothing but the mass. And when you will multiply this mass by G, as I said before, mg is giving you the weight, and this weight is nothing but the force. So as I said, that this force we have used here, and we are getting this simple formula, which is P is equal to rho GH. So this is something which we can do for the derivation of this formula. So sometimes they ask this derivation as well. So very simple steps you can follow, 2-3 steps, and you will get this formula. Here again, there are few things about the pressure, and particularly when you are talking about the fluid, you know that fluids may be gases or liquids, and in a fluid is a collection of molecules that are randomly arranged and held together by weak cohesive forces and by forces exerted by the wall of a container. Simply, you can say it's a substance which can flow. Anything which can flow will be a fluid or is a fluid. So simply you can say both liquids and gases are fluids. So this is something actually you have already studied, but just to recall those points, we are just emphasizing on these you can say points which we have studied. As you know that the fluid pressure increases with depth. Yani if you are going somewhere, suppose if you are drawing these lines, so what will be the situation? At this point, only this height of the liquid is above the point, so you have a pressure only of this much height. But when you will go inside slowly and gradually, the height of the liquid above the point will be more and more, and somewhere here at the bottom of the container you can see the total height of the liquid we have to consider. So this height is maximum, and simply you can say that the pressure will be maximum. So this is something which is very important. Water pressure increases with depth, as I just explained. Likewise, atmospheric pressure decreases with increasing altitude or height. What does this mean? Here actually we have to recall that suppose if we are considering the earth, then what will be the situation? Around the earth we have a region where the pressure or atmospheric pressure will act. Yani for all these points we have the you can say situation of the fluid, which is of course the gas or air. So the when you are moving up, the situation is that above, suppose this point, only this much air you will have, somewhere here only this much you will have, and so on. So at the surface of the earth, this much height you have to consider, but when you are going towards the you can say maximum height, then what is happening? Altitude is increasing, height is increasing, and the air above that particular point will be less. So the pressure P is equal to rho g h, as we have just studied. This h will decrease when you will go you can say towards the top. So this is very very important. By changing or by increasing the altitude towards the height or increasing the height, this h is basically not increasing, this h is decreasing when you are moving you can say towards the top or away from the earth. This h is decreasing. So with the altitude, with the increase of altitude, height will decrease. So remember this thing, and because of that, of course, the atmospheric pressure will decrease. So this is very very important. And what we are writing here, that atmospheric pressure decreases with increasing altitude. So I hope this point is also clear here. Consider a cylinder of fluid with height h as shown in figure. I have already explained this thing, so you need not to repeat all these points. So here we have already explained all these things, like pressure is P, rho is density, unit is given, g acceleration due to gravity or free fall, meter per second square, and h is the depth of the fluid or height of the fluid. So here you have the unit, which is meter. So this is all we have already studied. So you need not to worry about this thing. Now here are a few more you can say points, like suppose the pressure is a scalar quantity. What does this mean? That you have to recall that we have two types of quantities. One is the scalar quantity and another is the vector quantity. So when you will talk about the scalar quantity, this is the quantity which need not to have any sort of direction, but to explain vector you need the direction of the quantity as well. So here what we are saying, pressure is simply a scalar quantity, yani simply you can say that what is the pressure. So you need not to mention any direction, only you have to talk in terms of the height, rho and g, and you will get the idea that what is the pressure. The fluid density rho is assumed to be constant, of course, as I have already explained that if you are talking about the fluid in a particular you can say container, then the height of the liquid, of course, may have different heights or can be changed, but as far as the density is concerned for a liquid, it will remain the same or constant. And you know that the fluid is incompressible, yani there will be no change in the density of the fluid. You cannot compress the fluid. If you have suppose a glass of water, then in a glass of water, if you have of course like suppose up to this level you have glass of water and you are putting some pressure somewhere here, so you cannot compress this water. This is very very important. So because of that, the water has a particular density. Similarly, even if you have a you can say particular volume of air in a balloon, then you cannot compress that. Of course, if you will compress or if you will apply the pressure, the balloon can be burst, but the volume of the gas will not change. So this is important, and that's why we are using this term incompressible. The fluid pressure P is equal at all points having the same depth independent of the shape of the container. This point you have already studied in your IGCSE as well. And if you have suppose a container like this, and with this container suppose you have another container which is of this shape, and here you have another container which is of this shape. So if you have different shapes container, but the thing is that height of the fluid in all of them is same, and suppose this is the height, so what will happen? All of them will give us the same pressure. Whatever the shape of the container doesn't make any difference. So all these points will have the same pressure. So it doesn't make any difference if you have one shape or the other of the container. So this is important. This point we have already discussed, that the equation P is equal to rho GH allows the pressure due to the fluid to be calculated. Simply anything is that you can use this equation and you can use the atmospheric pressure with this equation to get the total pressure at the depth H. But again, I just want to mention this thing will happen only when the container is open. But if the container is closed, like I have just drawn here, like suppose if you have a container like this where you have the closed bottle like situation, suppose you have a cork here or cap here. So whatever, whether it's a you can say here you have the air filled or the fluid, any fluid like a liquid, then simple thing is that you can say the pressure will remain the same only because of this formula rho gh, and there will be no role of the atmospheric pressure. Atmospheric pressure will be active only when you will have the container with the open you can say situation like this. So this is what we have as far as the pressure is concerned. Now we are going towards another important point, which is the upthrust. Here, as you can see, the upthrust. So upthrust is basically upward force. So remember this thing, that always when you will deal with the fluid, there will be an upward force on the body. Like a fluid, how we can explain this thing? A fluid will exert a force upward on a body if it is partly or wholly submerged within it. This is because of the deeper into a liquid or fluid you go, the greater the weight of it, and so the greater the pressure. Any basic thing is that if you have a situation of a container, like suppose this is your container and you have anything inside, like suppose if you have a body here, so if you have suppose air only, then the top of this body will have another pressure, and from the bottom you have another pressure. Ultimately you can recall that the pressure is nothing but force per unit area. So what you can say that force is equal to P into A. So if you have two pressures, like here you have the you can say uh, top pressure, and here you can say bottom pressure. So when you will subtract these two, you will get the net pressure, and this will be of course the upward. So because of these pressures you will have two forces as well. So the downward force you will have and the upward force you have. So the difference of these two forces will give us an upward force, which is nothing but upthrust. So be careful and remember this thing, that the upthrust is always an upward force. Upward force. Now if you are dealing suppose with a situation like suppose you have here a liquid instead of using gas. If you are using a liquid, then again you will have the same thing, yani you will have upward pressure and downward pressure, and with these pressure of course you can say that here we have the area, and this area multiplied by these pressures will give us forces. The difference of these two forces will give us the resultant force, which is in the upward direction, and this will give us the simply the upthrust, which is the upward force. So this is very important, and in any fluid you will have the difference of forces, upward forces and downward forces, and of course as I said the pressure is also important, but ultimately you have to talk in terms of forces, because the force is the resultant force, and force is a vector quantity. So you have the concept of resultant force in that case. So this is something which is very important, and up first is the upward force. Here we can have a quick sort of derivation. If you are considering here a uniform cylinder of cross section area A and height S totally immersed in a liquid, then what will happen? Simple thing as that, like I can redraw the diagram. Like here you have a situation, and you said that I have suppose a body here, the area is A, and as I said that suppose you have a cylinder. So what is the situation here? The situation is that you are considering simply you are considering here like this is the area, and here you have the say we are considering here you have a fluid. Then as I said and explained before, that you have two you can say positions, top and bottom, and if you want to consider the you can say pressures, then at the top what will be the situation? Here you have H1, this is your H1, any height above the you can say top of this structure, the cylinder. Suppose A is the area. So what you can say that as far as the pressure at the top is concerned, here you have say PT, or the pressure at the top. So this is something which is P is equal to rho GH, we have already studied. So we are considering here H1, rho is the density of the fluid, and of course G is the acceleration due to gravity. So with the help of this, what we can say, we are getting a force which is F1, and this is basically the downward force. This is basically the downward force. So this is say your first force or first equation, and then when you will consider the bottom pressure, so of course the height of the liquid will be H2, and because of this height you will have the pressure at the bottom, and you can say that it is PB, and this PB is giving you the force at the bottom, and we can say that it is the second force. Of course this is the upward force, and in this case of course the H2 is important. Area of course is here, and both these areas above and below are same. So area is constant, density is constant, G is constant, only the height is different. So because of this height the force will change or increase. So what you can simply say that upthrust is the difference of these two forces. So F2 minus F1 will give you that particular force, which is the upward force. And when you will use these two equations, here you have H2 rho GA, H1 rho GA, and simply you can say that rho GA is constant. So H2 minus H1. So what is H2 minus H1? Simply you can say that this is the height here. This is the height here. So when you will consider this height, you can say that we can write this equation in this form, that rho GAH. Now the thing is that again we are going towards that particular thing. A into H is nothing but volume. So when you will consider this volume, this is V and this is volume of this cylinder. So be careful, volume of this cylinder. But when you will consider here the density and V. Now the thing is that which is very important. Here basically this density is of the liquid. Density of the liquid. Rho is the density of the liquid, but V is the volume of the cylinder. So these are two different things. But simple thing is that you can simply you can say state in this way that the volume of the liquid displaced by this body will be equal to the volume of the cylinder. So it means that if you have a volume V of the cylinder, the same volume will be displaced by this cylinder volume of the liquid. So simple thing is that you can write in this way that volume multiplied by density is nothing but mass, as we have density is equal to mass per unit volume. So when you will multiply these two things, density and volume, here you have this situation, density and volume. When you will consider, you will get nothing but the situation of, here you have this situation, density times volume is giving you mass. So what is the mass, or mass of what? Simply you can say mass of the liquid. And when you will consider this G with this mass, you will get weight of the liquid. So simply you can say that the upthrust is nothing but the weight of the liquid displaced by the volume of the cylinder. So this is very important. And this statement is termed as the Archimedes principle. What is this statement? Simple thing you can write somewhere here, that the upthrust on an object immersed in a liquid is equal to the weight of the liquid displaced by that object. So this is very important. Yani whenever you will you can say immersed a particular object in the liquid, what will happen? That object will displace a particular amount of water, and this will be equal to the, of course, the mg you have, and this mg is nothing but the weight of the liquid. So be careful, and this weight of the liquid will decide that what will be the upthrust on the body. Here we have number of examples and application of this upthrust. Like suppose if you are considering here, suppose a very simple question, you can say that if we have a pin, a small pin, the pin will sink, but a huge big ship is not sinking. So why it is happening? So same reason you can use, and simple thing is that the volume displaced by a pin, and suppose you have this pin, when you will use this pin, what will happen? The weight of the liquid displaced by this pin will be very small. So simply you can say in this case the weight will be more and upthrust, which is the upward force, will be small, and because of that what will happen? The net force will act downwards, and ultimately you can say that the pin will sink. But when you will consider a ship, a boat, a big boat, then what will be the situation? The weight of the liquid displaced by this shape or boat will be a huge big situation here, and of course the upthrust, any weight of the boat is less, and of course the force which is acting upward with the upthrust is a big force. Here you can use again U, and here we are using this F and U are the same thing. Any upward force is the upthrust. So if the upthrust is a big force, then what will happen? Of course the boat will float on the surface. So this is what we have as far as the concept of the upthrust is concerned. And as I said, that number of examples you have, you have a huge big aeroplane which is floating on the surface. Of course, you know that aeroplane is, you can say, flying in air. So when you will have this situation, upthrust on the your aeroplane will be a big upthrust, and because of that you have a situation that the aeroplane is flying without sinking in the you can say the air. So this is very important concept. Here I am giving you another explanation. Like here, suppose you have a weight W which is attached with spring balance, and here you have the situation that when the weight is hanging with this spring balance will show you here a tension. And simply what you can say, that in this case tension will be equal to weight, and T minus W is equal to 0. Yani there is no net force, and as there is no net force, so simply you can say that whatever the like suppose reading you have, say suppose it is 5 Newton, so 5 Newton is basically showing you the weight, because there is no net force is acting, and simply whatever the force you have is nothing but the tension. So the tension is 5 Newton, which is representing the weight. But if you have a situation, and the situation is that now you have filled this container with water, suppose, then what will happen? You will have a situation that I am showing here. Here you have the weight which is acting downward. Here you have tension, but as you can see here that the liquid or the fluid or water is giving you an upthrust as well. So what you can say, that there are two forces, T plus U, upthrust and tension, and here you have the one downward force. So simply you can say that what will be the tension here? This is W minus U, or you can write here we have T, which is W minus F. So here this T now is less than W. In this case T is equal to W, but in this case T will be less than W. It means that when you will sink something into the liquid, then what will happen? The tension here will decrease, so there will be an apparent change in the weight. So this is very important, that because of, you can write in this way, that because of the upthrust, the weight of a body immersed in a fluid decreases. So this is very important point to remember, that when you will have a situation like this, that you have completely you can say immersed body in the liquid, then you will have a situation like this. Any weight is acting downward, but there are two forces, upward forces, tension and upthrust. And as I have just written this equation, that T plus U, these are two upward forces, and of course if your body is somewhere at one position, then you can say that is equal to the weight. But ultimately what you can say, that the tension of course here is less than W, and this simple situation is, yani tension is less than W means that basically you are saying that the W is apparently decreases. And tension is basically showing us the weight of the body. So if the tension is less than the value, and suppose if you have this 5 Newton, so what will happen? 5 Newton was the weight, this is the downward force, but now suppose you have 2 Newton upward force, the upthrust, then what will happen here? As I said, this is weight, this is upthrust, so the tension will be is only of value of 3 Newton. So this 3 Newton shows that the apparent weight, because you are basically thinking in this way that whatever the tension will be here in the spring balance, this will give us the concept of weight. It means that when you will sink something or immerse something, not sink, if you will immerse something into the liquid, then the apparent weight of that body will decrease. So this is very, very important to remember. Ultimately, I will show you some sort of animations as well, but here you have the theoretical explanation. Here I just want to mention that if you are new on my channel, so subscribe this channel and press the icon, bell icon. So whatever the new audios we are uploading here, you can go through and you will get those audios immediately. And of course, if you like these videos, so press the like button as well, and share this, because other students can also get benefit of this lecture if and lectures or the use of this channel. So this is what we have as far as the upthrust is concerned. Here there is another explanation of upthrust, like suppose if you are considering here, if the weight of an object is greater than the upthrust, what will happen? It will sink. So this is very, very important. And if you have, suppose, as I have already explained, that if you have the body, like suppose you have an iron piece, what will happen? You have a particular volume, and this iron piece will displace a particular liquid or fluid, then that will give you the, you can say, magnitude of the upthrust. But when the weight of the body is greater than the upthrust, what will happen? Of course, you can simply say that we have a situation that the downward force is greater than the upward force, and ultimately we can say that what is happening here, you have upthrust, here you have W. So when you have W greater than upthrust, the body will sink. So this is very, very important, that if you are observing something which is sinking into the liquid, then simply you can say that the upthrust in that case will be less than the weight of the body. So this is very, very important. On the other hand, if you have a situation like this, that if the weight of, I have actually marked here, if the weight of an object is equal to the upthrust, it will float. This is also known as the principle of flotation. And here you have a situation that the liquid or the fluid displaced by this body is giving you such a upward force which is equal to the weight, then what will happen? As I have already explained, that when the W is equal to upthrust, then what will happen? W minus U is equal to 0, no resultant force. So simply you can say that the body is floating. I have explained this ship thing, and what I have already explained, I am just marking here. A ship made of steel can float because its internal hollow volume displaces a large amount of water, which in turn generates sufficient upthrust to keep the ship in equilibrium. Yani the liquid displaced by this huge big ship will give you the upthrust, and because the volume displaced by the ship is you can say giving you a big amount, so the upthrust is a big upthrust, and this is balancing your W, and the ship is floating on the surface of the sea, suppose. So this is what we have, and this is the equilibrium situation. On the other hand, if you will consider the example of submarine, then what will happen? Actually, in case of submarine, what will be the situation? A submarine can rise or sink at will. And if you want to take the submarine towards the bank of the river, you can do it. and if you want to float this on the surface of the water, then you can do it because it contains blast tanks. And if you have a submarine, like suppose if you have submarine like this, then simply you can say that here we have big tanks. When you will open these tanks, what will happen? Water will rush into these tanks, and because of that, the weight of the submarine will increase. And here you can control the weight. Remember one thing, that the volume of this submarine is fixed. Volume of the submarine is fixed. So the submarine is displacing a particular amount of water, and simply you can say that amount of water is giving you the upthrust. So you can say in this case upthrust is fixed, but when the blast tanks are empty, what will happen? The weight will be less, and in this case what will happen? The submarine will float over the surface of the liquid. But as soon as you will open these blast tanks, what will happen? As I said, that the water will rush into the submarine, and the weight of the submarine will start increasing. So when you will have a situation that of course the weight has increased, is greater than upthrust, so the submarine will go into the you can say sea or towards the bank, and simply you can say that there is a situation that the submarine is sinking. So this is very, very important. Here, as we have mentioned here, that the variable upthrust controls the up and down motion of this submarine. Be careful, variable upthrust is basically not the situation. As I said that the upthrust is constant, but why we are using this term variable upthrust? Variable with respect to weight, not its own. Yani the value of the upthrust is not changing, but we are using the term variable upthrust because we are just comparing this upthrust with the weight. So when the upthrust will be greater than or equal to the situation like this, here you have U is equal to W, your submarine is just floating over the surface of the sea. But as soon as the weight will increase and you will have weight greater than upthrust, then what will happen? Of course, the submarine will start sinking. What you can do at a particular point, or you can say at a particular depth, you can close the doors of your blast tank. So at that point, the weight will be equal to the upthrust, and of course what will happen? Your submarine will float at that point. So this is very, very important to understand. It means that you can control the sinking or rising of the submarine by controlling the amount of water which is going into the blast tanks of your upthrust. And basically you are controlling the weight of the submarine. As I said that the amount of water displaced by the submarine will always be the same. So whatever the weight of the submarine, but the amount of water displaced is giving us the upthrust. So upthrust is always same. Basically what we are doing, we are changing the value of weight. So this is very, very important. When the weight increases, the submarine starts sinking, and when the weight, or if you are just you can say pushing the water back into the sea or throwing the water back into the sea, then what will happen? The weight of the submarine will start decreasing. Upthrust is acting constantly, so it will move up, it will rise towards the surface of the river or the sea, whatever is the case. So this is what we have in case of your submarine. I hope it's clear. So this is something which is very important as far as the upthrust is concerned. As I said that we will inshallah see how we can explain this thing with the help of some sort of animations. Here, last but not least, we have a concept of viscous forces, and these are terms as the drag forces. So whenever you will have any fluid and the body is moving through the fluid, then what will happen? There will be a third force which will be because of the air friction or frictional force. So remember this thing that it is the frictional force acting on a body when the body moves through the fluid, a liquid or a gas, and dissipates in nature. Examples of viscous force is air resistance acting on a moving car and object falling in air. So these are few examples. So now the point is, here you have another situation, like suppose here you have a body which is moving upward. We are throwing this suppose ball in this direction, then what will happen? We have three forces now. One is the weight which is always acting downward. Another, here we have another force which is the upthrust, always upward, but the drag will depend upon the direction of the motion, and it is always in the opposite direction of motion. Yani if the body is moving up, the drag will be downward force, or the drag will be in the downward direction. Similarly, if you have the downward motion, then as I said, weight is always acting downward, upthrust is always acting upward, but this time the drag will also you can say in the upward direction. So remember this thing, that drag is always in the opposite direction of the motion. And here we have the situation that viscous forces arises in liquid because of, or fluids, because of the attractive forces between the your fluid molecules. Yani these fluid molecules will give you a sort of resistance, and here we are using the term viscous forces, and basically we are using another term which is the drag or viscous drag. So this is something which is important when we are moving in the fluid. We have three forces. One is the weight, another is upthrust, and the third is drag. Here you have to consider one very simple thing, is that the viscous force increases proportionally with the speed in laminar flow conditions. What is a laminar? Remember this thing, that when each particle of the fluid flows in a smooth path and the path of each particle do not cross each other, this is the laminar flow. Then suppose if you are say using a tap here you have a tap and the water is just going down. So all the particles of the suppose water are moving in a straight line parallel to each other, they are not crossing each other. So simply you can say that this will be the flow which is termed as the laminar flow. All the particles are in the same direction. So what will happen when you have this situation? Viscous force increases proportionally with speed in laminar conditions. So this is very, very important. Yani suppose you have a situation like this, as I said here, and you are just moving opposite in direction. Yani if suppose you are somewhere here, you are dropping something, then you are going in the direction. So what will happen? Of course, the particle will give you a sort of friction, and when you are moving upward, then again the particle will give you the friction, and these friction will be basically because of the you can say frictional forces between the molecules, and these are nothing but the viscous forces, drag forces. So be careful. Above a critical speed, the liquid flow becomes irregular and turbulent, and viscous force increases proportionally with the square of the speed. Actually, we need not to go into that detail, but remember this thing, that what is the turbulent flow or irregular? So you can simply consider the case, as I said here, that if you have a tap water, then all the lines are just like this, they are falling here. But of course, from a distance of the tap water, suppose you have a situation like this, that they are spreading like this. So you have the turbulent situation, and the water you can say are not, or water molecules are not moving in a straight line. So they are just, you can say they are irregularly moving, a movement you have, and this is nothing but the turbulent. So this is the situation where we will talk about the proportionality. here, but the square of the speed in this case. As I said that you need not to go into that detail, but just to give you the idea that what is the situation here. Basically, viscous drag is a complicated force. Like suppose if you have a sort of a small sphere, metallic sphere, and this metallic sphere is passing through or flowing through a fluid, then we can use this equation that F is equal to 6 pi eta RV, where eta is the viscosity. Again, as I said, that viscosity is something which we have not studied, but R is the radius of this sphere and V is the velocity. So you can say and see that in this case the drag is directly proportional to the velocity. But of course you will have other options as well, other conditions as well. So I need not to go into that detail, but basically this is something which you have to consider, and in our you can say syllabus only up to this you have to understand, and particularly in the logical questions or MCQs you will see questions based on the viscous drag, upthrust and weight. The relation of these three forces you will see in normally in your MCQ questions. So this is what we have. I hope these things are clear, and of course if you have questions related to this topic, you can ask me in comments, and of course I will try to give you answers of these questions as well. But here you have few very important points we have discussed. I will show you some animations as well for these topics which we have discussed. Okay.